So, folks on this side of the room, can we do it? Is it doable? Okay. There's still work going on? People on this side of the room, final numbers, final values, what do we got?
E minus 1 over 3.
Yeah, okay. So we get E minus 1 over 3. Okay, so I don't usually do mean things, but this was a little bit mean. Because this guy cannot be integrated. So there's no formula for this antiderivative. I gave it to this half because it's the hard part. So there's no antiderivative here.
Modifier, should you say there's no elementary antiderivative?
Ooh, what's the distinction between elementary and non-elementary?
Elementary means basic, using a basic technique.
So there's no antiderivative that involves e to the x, ln, polynomials, or compositions. So like any composition of lns, exponentials, additions, polynomials can't be done. There's no closed formula for this. So this one is just really hard, right? If we want to do this, this is very, very, very hard. However, in this order of integration, we can do the following move. So here, right, so when we integrate this is constant in y. Okay, so we integrate the constant. And now we've got something that has a elementary antiderivative. This is something that we can really calculate. Cool. So this one has a nice elementary antiderivative. Fubini's theorem tells us that these two things are equal. Okay, so even though this order of integration was quite difficult, we can still get that it has to be e minus 1 over 3. So if you're working on one of the homework problems and you find yourself in a situation like this where like substitution is not working, integration by parts is not working, it's really, really difficult, consider changing the order of integration. If you change the order of integration, you might get something where the algebra works out better. So this is another one of these homework assignments in our readings where there's a lot of questions of very similar types, right? So we're asking you to do 96 through 99. Again, once you feel like you've got the general idea, feel free to move on. Same thing, I think, like 74 to 79 are also assigned. So once you feel like you've got the mechanics of it, feel free to move on. I want to come back to that brain teaser about type 1 and type 2. Okay, so now I got to be really careful to get the labeling right. Is it yes, no? And then yes, no again. Okay. So we're missing these two corners, the things that are type 1 but not type 2, and the things that are type 2 but not type 1. So what we need is a region that is not bounded by functions, right? This region fails the vertical line test, right? So there can't be a function that's bounding this in the y direction. Okay. How can we make that same kind of thing work in these corners? How can we make sort of a region that's not bounded by functions? Yeah, sure.
It's myself down, but could you do that but in the x direction?
Do that in the x direction. Okay, that's reasonable, but this thing's symmetric, so how am I going to do that in the x direction?
Not with that one.
A bit louder? Okay, this is a good idea to get this working in just one direction, right? This one's sort of working in both directions. How can we make this happen just in the x direction? So I think Josh is onto something. Yeah, sure.
Two curves, one right below each other, so it's like a rainbow.
So it's like a rainbow. Yes. Yes, it is like a rainbow. So we need to be type 1, so we need to be bounded by functions. This. Yes, this will work, right? This is bounded by functions vertically. But it's not bounded by functions horizontally. Right? Cool. And we can do a little bit of a symmetry move here, right? If we have something in this box, its reflection should be something in this box. Cool. So there's many ways to make these shapes. There's many examples that could work here. So if you have something similar, that's fine. Very cool. We're getting into this kind of neat part in the course where we start caring about topology. So topology is the study of shapes and how shapes sort of have holes or lack holes. So as the course goes on, things are going to get more and more kind of topological. Like we're going to deal with integrating paths over boundaries like this. This space is very nice. So we're going to give a name to things that occupy this corner of the diagram. So that sort of bottom left-hand corner of the diagram is very special for us. It's the set of simple regions. And as we go on in the course, we're going to talk about why integrals over simple regions are sort of special and why integrals over these kinds of regions are sort of difficult or harder to deal with. But that will take us a couple weeks to get to. I want to remind folks that our term test is coming up quickly. Right? We've got not this Friday, but the Friday after. We're going to post an announcement on Quirkus listing relevant topics, just like we did for the last term test. Just before we break, are there things people want to know about the term test? Questions, things people want to know, so that I can address them in the Quirkus announcement? Yeah, sure. Right, yeah, good question. So we're going to cover up to Lagrange multipliers. Okay, so the material from this week on integration and change of variables will not be on the term test because you won't have adequate time to get ready for it. So all the business about type 1, type 2, simple, that will all be on the final exam. Okay. Any other things people want to know? Oh yeah, another question. What's 1.4 about? Area and length of, right, area and length, no, yeah, thank you for checking. Yeah, so area and length and polar coordinates, we're gonna do that next week when we get into change of variables. Cool, thanks folks.